Good morning mga students. So, balik kita ha learning packet 4. Basically, gin-try ko pag-standard iton aton topic for inorganic chemistry. Actually, for inorganic chemistry, I am following Shriver. So, chapter 4 niya is about acids and bases. Ang last ko kasi nga pinansol, makikita niyo mas makuro-kuro gud man adto. Kaya na namiling akong masuro sa yun hiya pag-approach. Kay baga nako konsensya lang ako. Pero the topic would be the same. I would see to it that the topics would somehow, if you try to read Shriver for inorganic chemistry, then it would be worth it. So anyway, skill building man good kita. So I'll solve problems. So for SP number 1, babalyuan ko na niya. First is identifying conjugate acid-base pair. So ini mo acid-base pair, usually common ini kan Bronsted acids and bases because there are usually two nga prevailing definitions or theoretical framework for your acids and bases. One of which is Bronsted-Lowry. Actually, Bronsted-Lowry niya ha ibang libro. Bronsted acids and bases. Nagkakaiba hera kay ani mo Bronsted acids and bases. It's about hydrogen. It's about hydrogen or the giving up of proton. So anyway, may discussion man na kini dito ka ng piso. Samantalang ang usa is Lewis acids and bases. So dito Lewis acids and bases, you're talking about electrons. So anong pagkakaiba nila? One big difference is, of course, ay mo Lewis acids and bases, they can be acids and bases even though they don't have that particular hydrogen. So haimo, and then you are not in bisan diri it imo solvent water. Because you can see your water for acids and bases, even for laboratory techniques, common iton acids and bases is using water as your media. Pag sumiring nga ni nga may pH siya, usually in water media ito ya, pero hindi ito may tubig niya. So man ka may suoy, may blood, may ano ito nga da, yung kukuha ano tin pH, may dani mo basic na solution na ammonium phosphate, okay, phosphoric acid, mga sa dito hydrochloric acid, pero may titira may tubig. Pag diri 100%, of course, kay diri lo titira nakaka 100% naturally. Talag sa landuro. Kay delikado liwat. So again, for takon pen. Ha? So for Bronsted-Lowry, permanent titiada nga present nga hydrogen. So iti mo hydrogen, pag hinuan na hatag hydrogen or gitatawag iti danay nga proton. Proton. Danay kasi iba nga kuan language. Gitatawag hinot na hatagin proton. Proton it hydrogen kay ano, kay imo hydrogen kasi kung babalik ko niyon imo atomic orbitals, imo hydrogen is may daniya nucleus, its solo dito is one proton, tapos hagawas niya may daniya 1 electron. Now, giving you one proton ngan 1 electron ngan waray hitira neutron. Itot imo atomic weight is 1 because of that weight of your proton. Now kung ni electron lumakat, makikita naton nga hydrogen, this is hydrogen ha, may daniya nucleus as may daniya usa nga shell. Balik kita ito dida. LP1 or LP2. So may daniya usa nga shell nga may daniya usa nga electron. Pag lumakat ito nga electron because of course reactions or anything, para hindi na hinabo. Spontaneous kasi niya, I mean simultaneous. Pag lumakat itong electron, makikita natin nga sulod ito mo hydrogen is usa na ka proton. Sang litit iya itong ngaran na is H+. And that is why it is called proton. Bisan hydrogen plus ito hiya. H+. So because that positive kay waray na negative, di ba? Os positive nga negative, positive man ang proton tapos negative ang electron. So itira yung electrical charge kung ordinary ka nga hydrogen is 0 because the positive charge of your proton is cancelled off by your electron. Now, when reaction happens in acid and bases, usually the electron leaves hydrogen or hydrogen leaves without the electrons. That's why it becomes H+. dinhi nga naging ginkuha talaga an term nga pH, because that is the power of your H, the power of your hydrogen. Amo ito ginkuhaan, but actually that H plus igahatag ito niya. So from Bronsted acids and bases, kung hino ang nahatag hit nga H plus, gintatawag yang acid. Okay? Tapos kung hino ang nakarawat, han H plus, amo ito't gintatawag nga hinot nakarawat ito, didi of course sa right side kay product naman itiya. Of course, the reaction happened kay ginghatag niya tapos may kumarawat. So kung hino ang kumarawat, gintatawag ito nga conjugate base. Kay pagka diha right, nagiging base na kasi ya. So conjugate base ito ya. So amo ito ya. So makikita natin didi reaction, hinon humatag. Makikita natin nga NH4 didi NH3. So, ibig sabihin, amoy niya ang kumarawat. So, this is your conjugate base. Conjugate base. So, hino man ang humatag din hydrogen? Adi. So, this would be your acid. It adi right side, tinatawag nga conjugate. So, conjugate acid, conjugate base. So, adi ang humatag, adi in iya gintagaan. Diba? So, this is the acid, this is the conjugate base. Magpadis itira. And in this one, amo niya an substance nga tikarawat. So, we call this the base. Okay, of course, ano mo kareakan imo acid is the base. Nga di kita. So, this is the base now, and this is your conjugate acid. One thing nga makikita niyo itong acid-base reaction is this double arrow. I-double arrow kasi, it karasigon ito that both reaction happens. Pwede mo talaga baliktaron nga reaction. And actually, what happens in equilibrium, because we're talking about equilibrium, nahihinabot equilibrium is, ini kasi nga double arrow, as a number is being established, is na-fix ito hiya, kay tungod nga an imo rate of forward, ito nga, one tipakade, rate of forward reaction is equal to the rate. I'm talking about rate ha. Talking about rate. Ang kalaksi, ang paghimo ni rahadi, ang kalaksi, ang pagbalik nga di, is the same. That's why it is in equilibrium. Itaton pag-measure iton reaction, or usually pag-analyze iton acid-base reaction. Of course, in reality, kung gimbubutang naton, ginuhuwad naton ito sa nga acid nga dahiton base, of course, kay acid base man latira, kailangan mo itong time. Kailangan mong time before nga equilibrium mahinabo. So, usually, adat aton computation with respect to time. So, ang kinetics, gintatanggal naton. Nga gina-assume naton nga adi lahira, kinetics meaning ang pag-progress sa nimo reaction. So, iba't hilap nga topic, medyo complicated ito ya. Pero nga di kita ito lahan after han imo pag-react. I mean, ang pag-forward ng pag-backward is pareho na. It is actually reacting, but pareho na ra ang rate at the same rate. So, basically, your acid is HF and your conjugate base is NH4 plus for this problem. And your base is NH3 and your conjugate acid is fluoride. Ito nga AQ, that is aqueous. May tubig ito dida nga aada. Okay? So that's the solution. Kaya malan pa kaya na, di ba? Identify the conjugate acid-base pairs in the reaction between ammonia and hydrofluoric acid in the aqueous solution. So those are the answers. Thank you, guys.